Experiments during the past decade have also shown that separate particles can influence each other again over enormous distances as if they were endowed with a kind of an ESP. So these and similar experiments have befuddled scientists for decades. Some of the greatest physicists have described them as impossible to intuit. How can quantum physics be so impervious to metaphor, to visualization, and language? Amazingly, if you accept a life-created reality at its face value, all of it becomes straightforward to understand. So take the undeniable logic, or the seemingly undeniable logic, that your kitchen is always present. You think that its contents assume its familiar shapes and colors, whether or not you're in it. But consider, the shapes, colors, and forms known as your kitchen are seen because the particles of light from the overhead bulb bounce off the various objects and then interact with your brain through a complex set of retinal and neural intermediates. But on its own, as you heard from the previous speaker, is that light doesn't have any color, nor any brightness, nor any visual characteristics at all. It's merely an electrical and electromagnetic phenomenon. So you might think that the kitchen was there in your absence, but unquestionably, the reality is that nothing remotely resembling what you perceive as your kitchen could possibly be there without your consciousness interacting with it. Quantum physics comes at it from a much harder angle and arrives at the same conclusion. So at night, you click your lights off and you leave for the bedroom. And of course the kitchen is there unseen all through the night, right? So, in fact, the refrigerator, it turns out, the stove, and everything in your kitchen are composed of a shivering swarm of energy. And the results of quantum physics, such as the two-hole experiment and others, tell us that not a single one of those particles in any of those objects actually exists in a definite space until you observe them. Rather, they exist in a range of probabilities, waves of probability, as Max Born, the German physicist, once said. So outside of that fact, there's really nothing there. They're just statistical probabilities of particles existing in certain locations. So if they aren't being observed, they can't be thought of as having any real existence, either duration or position in space. So it's only in the presence of the observer, that is when you go back and get a drink of water, that the mind actually sets the scaffolding of these particles in place. And it's not until the mind actually lays down the threads somewhere in that haze of probabilities that's described by the uncertainty principles, can they be thought of as being either here or there, or of having actual position or a physical reality. Indeed, it's here where biocentrism suggests a very different view of reality. Most people, both in and outside of the sciences, imagine the external world to exist on its own with the appearance more or less that resembles what we see outside us, or what we see ourselves. So animal or human eyes, according to this view, are merely clear windows that accurately let in the world. So if the personal window ceases, such as in death, or is painted black, such as in blindness, that in no way should change the continued existence of this external reality. So a tree is still there, the moon still shines, whether or not you're looking at them. And they may have an independent existence. True, a dog may see autumn maple in shades of gray, can't see color, or an eagle may be able to perceive greater detail, but most creatures, according to this way of thinking, basically apprehend the same object, the same reality, which persists even if no eyes are observing. But this issue of is it really out there predates biocentrism. Again, once you fully understand that there's no independent external universe out there outside of biological existence, the rest more or less falls into place. So where exactly is your refrigerator? Where in the universe is it located? So start with everything that's currently being perceived. This room, for example. We all think it lies in the external world, but we've all already seen that nothing can be perceived that isn't already interacting with our consciousness. So since the images aren't imaginary, it must physically be happening somewhere. So the human physiology textbooks are very clear about this. They say, you know, that the eye responds to particles that deliver little bits of energy that are, hit the retina or photoreceptors, and then they're channeled back through these heavy-duty cables to the back of the brain, where the perception of the images actually occurs physically. So this process is augmented, of course, by other parts, nearby parts of the brain that are as vast as the hallways of the Milky Way. Thus, according to human physiology textbooks, that is where actual colors, shapes, and movement happen. And that's where we perceive and cognize things. But if you so can you actually access this visual part of your brain? It's easy. You're already doing it effortlessly right now with every glance. Custom says that what we see out there is that's outside us. But such a viewpoint is necessary in terms of language and utility, such as please pass the butter that's over there. But make no mistake about it, the butter itself only exists in your mind. It's the only place where visual images are perceived and hence located. So explained in the language of biology, the brain turns impulses from our senses into an order and into a sequence. As the light bounces off the butter, various combinations of different wavelengths enter into our eye and then deliver the force to trillions of cells. And then in the brain, this information, which of course has no color in and of itself, appears as a yellow block of butter. Even the smell and texture of the butter is experienced in the mind alone. So bottom line is the butter isn't really out there, except by conventional language. The same is true for all perceived objects. Even the brain itself, the cells, electromagnetic events that we detect with our instruments, all of these are already been given a spatial temporal structure that the mind imposes. So we may imagine that there's two worlds out there, one out there and one inside our skull. But this two-world view is a myth. As we've seen, there's only one visual reality that exists, and that's the one that requires consciousness in order to manifest. Nobel physicist John Wheeler once said, "No phenomena is a real phenomenon until it's an observed phenomenon." The major handicap in adopting this new viewpoint is that language is created exclusively through symbolism to divide nature into parts and into actions. And even if you're well acquainted with the limitations of language, we always have to be on guard to dismissing things such as biocentrism too quickly because it doesn't at first glance seem to be compatible with the ordinary, customary construction of language. So the challenge, alas, is to peer beyond our habitual ways of thinking and to go beyond the tools of thinking, the thinking process itself. We need to grasp the universe in a way that is at the same time simpler and more demanding than we're accustomed to. So quantum mechanics describes the tiny world of the atom and its constituents with stunning accuracy. But in many ways, it threatens the absolute notions of space and time. When studying subatomic particles, the observer appears to alter and determine what is perceived. The presence of the experimenter is hopelessly entangled with the attempt to what you're observing and the result that the scientist gets. In 1964, John Bell proposed an experiment that could determine if separate particles can influence each other instantaneously over great distances. First, it was necessary to create these bits of matter that shared the common wavelength, wave function, using a special kind of crystal. And these particle pairs are called entangled particles. And we know that everything in nature has both a particle nature and a wave nature, and that the particle's behavior exists only as probabilities. Objects assume particular places or particular motion when its wave function collapses. So what accomplishes this collapse? Messing with it in any way. So hitting it with light, taking its picture, would instantly do the job. But it increasingly became clear that any way the experimenter could possibly take a look at what was going on collapsed the particle, or the wave function into a particle. So as more sophisticated experiments were devised, it became obvious that just mere knowledge in the experimenter's mind is sufficient to cause the wave function to collapse. That was freaky, but it got worse. If the wave function of an entangled particle collapses, so will the other, its partner. So when they're separated, say, by the width of a universe, this means that if one particle has an upspin, when you look at it, its other particle instantly go spin down. And it doesn't matter where it is. So this has been done over and over using fiber optics, and it turns out that the act of observation does indeed instantaneously cause the particle to collapse and to take on the opposite spin. And they act as if there's no space or time between them. And experiments from 1997 to 2007 have shown that this is indeed the case, as if they're endowed with a kind of ESP. And they prove that Einstein's insistence that nothing can influence anything faster than the speed of light is wrong. Rather, the entities are floating in a field of a field of mind, as biocentrism would maintain, that's not limited by this external space-time that Einstein theorized a century ago. But no one should imagine that there's only one aspect of quantum theory that supports biocentrism. We can go through other ones, but again, Bell's theorem has been shown experimentally to be true over and over. And before Bell, it was thought to be increasingly possible, though iffy, that local realism, that is an objective, independent universe, could be the truth. And before Bell, the people also clung to the old assumption that physical states exist before they're measured. And before Bell, it was widely believed that particles had definite properties, independent of the act of measuring. But all of this is finished for keeps. And quantum theory also casts doubt on the existence of time itself, which is very important to any fundamental look into the nature of the cosmos. And it turns out time is a biocentric fabrication. When people speak of time, they're usually referring to change. But change isn't the same thing as time. When you measure anything's position exactly at any given instant, what you're really doing is locking in one static frame of, say, for instance, of a movie, as in a film. And conversely, as soon as you observe momentum or movement, you can't isolate those individual frames, because momentum is the summation of many frames. So sharpness in one parameter induces blurriness in the other, Heisenberg's uncertainty principle. So to understand this, consider the movement, consider you're watching a film of an archery tournament. The archer shoots the arrow and the arrow flies. The camera follows the arrow's trajectory, and the archer's bow goes towards its target. Suddenly, the projector stops, and it locks onto a single frame of a still arrow. And you stare at the image in the middle of mid-flight, and you know its position with great accuracy. It's just beyond the grandstand, 20 feet above the ground. But you have lost all information about its momentum or where it's going. Its velocity is 0. So its path, its trajectory is no longer known. It's uncertain. And so time is simply the animal sense that animates the still frame, so to speak, of the spatial world. It's our tool of perception. So at each moment, we're on the edge of a paradox that was described by the Greek philosopher Zeno a very long time ago. Since an object can't occupy two places simultaneously, he contended, an arrow could only be at one place at any given instant in its flight. So to be in one place, however, is to be at rest. So an arrow must therefore be at rest at every instant of its flight, and therefore motion is impossible. But is this really a paradox? Or rather, is it proof that time, which involves motion, isn't a feature of the external spatial world? Rather, it's a conception of thought. So it's not really a paradox. So in addition to the uncertainty principle, there were other experiments that confirmed Zeno was right. Scientists have proved in the quantum equivalent of demonstrating that a watch pot doesn't boil. This behavior is known as the quantum Zeno effect. And it turns out to be a function of observation, and it turns out that the act of actually looking at an atom prevents it from changing. So theoretically, by the tenets of the quantum Zeno effect, if a nuclear bomb were watched intently enough, it wouldn't explode. Not that I recommend you trying it. You'd actually have to watch it, keep checking its atom every million trillionth of a second, which would be pretty tough to do. But they've actually done in real experiments where they use beryllium ions at the National Institutes of Standards and Technology, where they've actually shown this to be true. There were new versions that were just published actually a few months ago. So it's hard to believe that this could be real. I mean, this sort of a bizarre effect. The problem lies not with the experiments, but with our way of thinking, with our failure to accept the evidence. So while Zeno's paradox can be explained through these sophisticated mathematical concepts, mathematics is just a way to quantify phenomena, and it shouldn't be considered a replacement for it. The whole idea of science is to understand what's going on in the world in ways that we humans can understand. So the uncertainty principle is a fact. Quantum Zeno effect is a fact. And biocentrism is the only humanly comprehensible way to explain them. And quantum phenomena are only weird in the context of the existing scientific paradigm. And this isn't just idle philosophy. This concept has been supported by a series of recent experiments. In 2002, scientists actually showed that particles of light, photons, knew in advance what their distant twin would do in the future. So they tested the communication between these pairs of photons. They let one photon finish its journey, and it had to decide whether it would be a wave or a particle. And then the research actually stretched the path of the other particle, so it took a little longer to reach its detector. However, you could add, the experiment could add a scrambler to mess up the photon into that second path. And it turned out that that first particle knew before you actually added that scrambler whether you would or you wouldn't. So that was weird. So you say, okay, that's crazy. And they've done more experiments. So, okay, consider another experiment that was just published a couple years ago in the prestigious scientific journal Science. Scientists in France shot photons into an apparatus, and they showed that what they did could retroactively actually change something that had already happened in the past. So what happened is they put these photons into the apparatus, and it had to go through a fork. And as it went through the fork, it had to decide whether it was going to be a wave or a particle. And then it went on its way, and later on there was another fork. And the experimenter had the ability to click on a switch, an electronic switch, to decide what to do. And what that experimenter did then, right now in the present, actually changed what that particle did at that fork. That's real. We live in that same world. Now, physicists and scientists like to get out of this by simply saying there's two worlds. There's this small world, that applies to quantum phenomena, and then there's this macro world where everything's different. So the laws of the universe are different for you and I, and somewhere, I don't know whether it's here or there, the laws of physics change. And it turns out that that has been shown, not only does it not make sense, but it's been shown experimentally to not be correct. There was a paper actually in Nature last year that actually showed that entangled particles, when they were separated, actually were able to act indeed as if there was no space or time between them. There was an experiment that was done with these molecules called buckyballs, these huge carbon-60 molecules, and they actually in the macro world, and they actually turned out to exhibit the same quantum properties. And then there was an experiment done in 2002 with crystals, and they actually showed quantum ridges that were ½ an inch high. So again, okay, so those laws apply there, but where do they stop? Somewhere the laws change. It's just crazy, and there's no basis and reason. And more importantly, more and more experiments, quantum superposition, are showing that those characteristics that we are observing in the micro world happen in the world of you and I here in the real world. And that's where you start running into problems. This is where biocentrism tries to put it together to make sense. So in conclusion, and I just got my 2-minute thing here, we think that there's an enclosing wall, a circumference to us. But Bell's experiment implies that there are cause-effect linkages that transcend our ordinary classical way of thinking. The walls of space and time are illusions. Science is just beginning to grasp the nonlinear nature of reality. Heisenberg, whose famous uncertainty principle transformed our understanding of the world, once commented, "Contemporary science, more than at any previous time, has been forced by nature herself to pose again the question of the possibility of comprehending reality by mental processes. Alas, the evidence, the weight has the weight of a boulder, and shall our vision continue to flow over it? We're not just a collection of cells and molecules that classical science describes. Hans Pagel, the esteemed theoretical physicist, once stated, "If you deny the objectivity of the world unless you observe it and are conscious of it, as many prominent physicists have, then you end up with solipsism, the belief that your consciousness is the only one." And that reminds me of, well, the first thing is I should say is that I think Pagel's is right. The only thing here is it is not just your consciousness that's the only one, it's our consciousness that's the only one. So the old Hindu poem says, know in thyself, in all one same self so, banished dream that sunders part from whole. The mind transcends space and time in that they're its tools, not the other way around. This concept of reality dissolves away human individuality. Sometimes, said Thoreau, as I drift idly on Walden Pond, I cease to live and begin to be. The walls of space and time are illusory. This is the prelude to immortality. We're forced to recall the words of the English poet John Doe. Never send to know for whom the bell tolls, it tolls for thee, and to understand them in a more scientific way. The great naturalist Lauren Isley once said, there are very few youths today who will pause, coming from the biology class, to finger a yellow flower or poke in friendly fashion at a sunning turtle on the edge of the campus pond, and who are capable of saying to themselves, we are all one, all melted together. That's it.